Welcome everybody. Thank you for attending my talk, especially while there are so many of you. Really great. We're going to talk about the intersection of TDD and Gen AI today, and we're going to see if this is a perfect pairing. So I would like to start with an introduction. Why am I here talking about this subject? So last year I had a talk called The Battle of the AI Coding Assistants. I gave it at multiple conferences, multiple meetups, also in this one last year. And in this talk, I showed off features of different AI coding assistants. Think GitHub Copilot, JetBrains AI Assistant, but also good old JetGPT. And one of the features that I showed off was the fact that they are pretty good at generating tests. So how does that work? You as a human, you write the implementation, you ask the AI to come up with tests, and in most cases, it comes up with a happy case. In most cases, it comes up with a few edge cases. And if you're still not happy, you ask for more. So this works really well. After one of those conferences, somebody came up to me and asked, why don't you do it the other way around? And I said, the other way around? What do you mean by the other way around? And she said, now, what if you as a human write the tests and then ask the AI for an implementation? I said, wow, that's an interesting idea. I don't know if it works, but I'm going to investigate and I'm going to get back to you. This investigation led to this talk. So the second thing I would like to do is in the section of the title. So let's have the title again. The title is TDD and Gen AI, a perfect pairing. There are 3 IT concepts in here, and the first 2 are plain obvious. The first one, of course, is TDD, test-driven design. And the second one, also really obvious, Gen AI. But there is also a third IT concept in there. Who dares to guess? Wow, tough crowd. Okay, cool. The third one is pair programming. So that was hidden in the subtitle. So what we're going to do, we're going to take those three IT concepts and we're going to see if we can combine them into something new. But before I'm going to do that, I'm first going to take a few minutes to talk about those 3 concepts so we're all on the same page. So I would like to start with Gen AI, and JetGPT is the most famous one. It was introduced 2 years ago. It feels like so much longer, but it's already only been 2 years with us. And since then, a lot has changed because every big industry giant in the IT has their own chatbot nowadays, and they all have something in common. They all run on a technique called large language models. And those models are pretty good at generating text and also pretty good at generating code. And that's the feature that we're going to use today. Then the second IT concept is test-driven development. So people hold entire conferences about this subject, but I'm going to boil it down for this presentation to write tests in advance. And this is better than doing it afterwards for multiple reasons, but there are 2 reasons I really like. And the first one is the fact that if you first write your implementation and then your test will be biased by your implementation, and we do not want biased tests. Secondly, I really believe the following. The more time you think about something, the better the end result will be. And when you first write your test, you think a lot about your implementation, and therefore you will write a better implementation. So those are the things I really like about TDD. And it works really well with pair programming. So let's talk about pair programming. So pair programming is really simple. You write softwares in pairs. So you sit together behind one computer and you write software. Normally you do this, we have 2 roles. So we have the driver, that's the one sitting behind the keyboard writing the software. And we have the observer or navigator, and that's the person who's giving live feedback to your code, and that's the person you're discussing with while you're writing the code. Also, a thing that you see a lot while doing pair programming is the fact that one person writes the test, you switch chairs, and then the other person writes the implementation. So let's see if we can combine those 3 concepts into a new concept. Can we create a perfect tripling? So what we're going to do, we're going to pair program with Gen AI. The human will write the tests, and the AI will try to write the implementation. I call this test-driven generation. So actually, tests have a double purpose in this idea. And I talked a lot already about the first purpose. Tests are the input for this idea. So you as a human write a test. We give them to AI and we ask for an implementation. But there is a second purpose, and the second purpose is probably its most important purpose, because the second purpose of test is checking if the output of the large language model, the implementation, is a correct implementation. And this is really important because by now everybody has been using LLMs for 2 years, and you all know that those LLMs sometimes tend to make things up. And that's a problem, especially when we asking the LLM to come up with a proper implementation. And to illustrate this point, I'm going to tell you a story about Air Canada. So there was a story in the news about in the beginning of this year about Air Canada, which is an airliner, and they have a website, and on their website was a chatbot. And a customer was talking to the chatbot. No, sorry, I'm telling it wrong. Let's start over. So they have a chatbot, and Air Canada decided to improve the chatbot by adding a large language model to the chatbot. And this in itself is a proper idea, because then your chatbot will but the sentences from the chatbot, the responses will be more natural, more human-like. So the following happened. A customer was talking to this chatbot, and as you probably already imagined, the chatbot started to make things up. And they were talking about refund policies, and the chatbot started to make up refund policies. The customer was foresighted, made screenshots of the discussion, and then a few weeks, nothing happened. But after a few weeks, the customer called the help desk with actual humans behind it, and he said, I would like to refund my ticket. And the people behind the help desk said, sorry, that's not possible. He said, yes, that's possible. Look, I have screenshots. The chatbot told me it's possible. I can refund my ticket. And the people said, no, the chatbot made a mistake. But the customer disagreed and went to court. And the judge totally agreed with the customer. The judge said, I don't care if a human or a chatbot puts something on your website. If it's on your website, it is true. Therefore, you have to refund the ticket. The next day, the chatbot was offline. So I think this story really illustrates the problem we nowadays have with large language models. So they're pretty good at the first 95%, but the last 5% is the important part. We need output of large language models that we can trust for the full 100%. And lucky for us, we developers, we have a way to check the output of the large language model because we have our unit test. So we run the unit test against the output of the large language model. So my name is Bouke Nijhuis. I'm the CTO at a company called Sync ICT, and together we're going to see if TDD and GenAI is a perfect pair. So I created a little schema to show off our way of working, and I'm going to start with a happy flow. So I'm going to start on the left, and then we'd go straight to the right. Afterwards, I will discuss the loops in the model. So on the left, we start with tests, and those are input for the GenAI. We ask the GenAI to come up with an implementation that passes the test. Remember, this is happy flow, so we get a perfect implementation, and that means all tests will pass. That means we follow the yes arrow and we're done. If you trust your test, you have production-ready code. Unfortunately, in the real world, things go wrong, and that's why we have loops in the model. So we have a small loop underneath GenAI. I call this the code loop, and a big loop on top. I call this the test loop. So the small one, the code loop, is necessary because sometimes GenAI comes up with an explanation instead of an implementation. That doesn't work. Sometimes GenAI comes up with partial code or non-compiling code. Not good enough. You cannot run tests against that. So then the top loop, the test loop, sometimes not all tests pass. If that's the case, we extract the error, feed it back to the GenAI, and ask for an implementation that will also pass the test that failed just before. And this is how we get a feedback loop. So, demo time. So what I'm going to show you, I want to show off the process. So we're going to start really, really simple. So I created a test called the odd-even test. Let me show it to you. And as you can see, it is really, really simple. It's a JUnit 5 test. It expects an object called odd-even to be there, a class odd-even, I should say. And this class has one method called isEven. If you provide it with a even number, it should return true. And if you provide it with an odd number, it should return false. So really, really simple. Don't worry, I will step up the game during the presentation. There will be more interesting examples. This is just to show off the procedure. And I have a choice for the audience. In my left hand, I have the blue pill, which is ChatGPT. And in the right hand, I have a red pill, which is Claude. So who prefers ChatGPT? Raise your hand. Okay, who wants me to do the demo with Claude? Oh, wow. Claude easily wins. Okay, cool. We're going to do Claude. What I'm going to do, I'm going to copy the code. I'm going to go to Claude. I expected Claude, so thank you. I also have ChatGPT, so I am prepared. So we're going to ask, please implement a class that passes this test. And I'm going to paste the code. I'm going to press enter, and now we just wait for a second. We're on conference Wi-Fi, so it's always a bit of a thingy. But hey, look at that. We get an implementation back. And as you can see, it looks like a proper implementation. But luckily, we have tests to check if it's really a proper implementation. So I'm going to copy this. I'm going to go back to my IDE. I'm going to go to the test subject. Notice that I have a dummy implementation here with an incorrect implementation. I'm going to select everything. I'm going to paste it. I'm going to go back to the test. And I'm going to run the test. And we hope for a green check mark. And look at that, green check mark. Okay, this works. But okay, this was a really, really simple example. I understand why you're not standing on your chairs and applauding. We're going to step up the game. So the next thing we're going to do is prime number generation. And again, I have a test for that. Prime number. This is the test. Again, it's pretty simple test. We expect a class called prime number generator to be there. It has one method called generate. It takes an integer as input. This integer denotes the upper bound of the prime numbers to generate. And if you ask for 50, we expect this answer. So, doable, right? Again, I'm going to copy everything. I'm going to go to Claude. Normally it's pretty smart. I just can paste the code and it remembers from the previous question that I want an implementation. And look at that, there's an implementation. We're not going to spend too much time on reading the implementation because we have tests to see if they are correct. So I do exactly the same. Again, dummy implementation. Select everything, paste the code. Back to the test, run the test, and let's hope for a green check mark. Again, a green check mark. Okay, this also works. I'm really happy. The principle works. Thank you for coming to my presentation. Enjoy the remainder of the conference. No, just kidding. Thank you. Thank you for the applause. I'm really happy that the principle works, but I have two major issues with the current solution. And the first one is really simple. There are too many manual steps. And what do we programmers do when we have too many manual steps? We automate it. Thank you. It's like you read the slides. So let's automate this. Just to explain why we should automate, let's rehash the steps I just did. I copied code from my IDE. I went to a browser. I typed in a prompt. I pasted the code. I pressed enter, wait for the answer, extracted the code, went back to my IDE, went to the test subject, pasted, back to the test, run the test, press the green triangle, wait for the outcome, check the outcome. Only talking about this makes me tired, so we really, really have to automate this. And so that's what I try to do. And that sounds simple, right? You saw me just doing it. I was in my IDE, went to my browser, typed a little bit, wait, copied a bit. How difficult can this be? So yeah, it was a little bit harder than I expected. I expected me to take 3 to 5 evenings to build a tool that would automate this for me. Yeah, in the end, it took me 10 to 15 evenings and a few weekends. But I learned something. I learned that the IDE does a lot of work for you. And of course, we already know that the IDE does a lot of work for us. But in this project, it became really apparent. And I will circle back to this in a few minutes. In the end, I had a tool called the test-driven generator. And that's the tool we're going to play with in a few minutes. But before we're going to play with it, I first want to take you through all the little steps that it takes. So probably you recognize this as part of the schema that I've shown you before. This is the left part. And the first thing that you have to do, you have to call an API of a Gen AI. I started building this tool in the beginning of this year, and I started out by using ChatGPT because that's the one I was most familiar with at the time. Later in the process, I also switched over to other ones to see which ones were better. This is not hard, but it's work. You have to call an API, you need a key, all kind of work you have to do, but hey, it's just work, one evening. Then you have to interpret the reply. And that sounds really simple because you just saw me doing it in a browser, right? It was just a pop-up and I could just copy the code. If you use different LLMs, interpreting the reply isn't as easy as it seems because all the LLMs use a different way to denote what is code and what is text. So this is more difficult than you think. Then we have to create a file. And this file needs to have the proper file name because as you all know, if you use Java, the file name should be equal to the public class name. So we need a feature to extract the public class name from the code, and then we have to create a file. Then we have to create this file in the right location, because if your code contains a package keyword, the part behind the package has to be equal to the folder structure where your file resides. So we have to be able to extract the package part, and we have to be able to create directories. Then we go to this part. Then you have to compile both files. I didn't see that one coming. I'm using IntelliJ as my IDE. I never think about compiling files anymore. Who thinks about compiling files? The IDE does that for you and it just works. Always, at least 99.9% of the time. Then I have to load both classes. The test file that I use as input, but also the implementation from the LLM. Didn't think about it. This is typically something that the IDE does for you. Then I had to add the test library. So normally when I start a project, I add JUnit in the POM and I forget about it. But now you have to load JUnit in the tool, otherwise it cannot run tests. Didn't think about it. Then you have to run the test from code. Yeah, I always just press the green triangle. But apparently you can also run tests from code, and it's not difficult, but it is, again, work you have to do. Once all the tests pass, I copy the implementation back to the project where the test file was, and so you can directly use it. So then the big loop, the test loop. If not all tests pass, you have to extract the errors. Not difficult, but hey, you have to dive into memory structures, extract which test failed, and then feed them back to the GenAI. While I was doing the demo, you saw me the second demo with the prime number generator. I just pasted the code, and Claude was smart enough to remember that it had to write an implementation. That's because if you do things like this in a browser, it has context. It remembers what you talked about before. This is not the case when you use an API. I didn't know this. So you have to build a context mechanism yourself. And lastly, I started out this project with a few system out print lines, like every project. But every time when you talk with an LLM, as you all know, LLMs generate a lot of text. I needed a proper logging solution to keep track of what was happening inside the tool. So I just told you I started out by using ChatGPT, but I also heard more and more about local large language models. So I decided, let's try those. And they were easier and faster than I expected. I expected them to be really hard to set them up, like 20 manual steps and a lot of error-prone steps. Turns out you just download a tool and then you run a model. They were also much faster than I expected. I expected answers to take up to minutes. At that time, I had an M1 MacBook, and answers took about tens of seconds. This is an M3, and it even generates answers under 10 seconds. So it's pretty fast. There are lots and lots of local coding LLMs out there, but in the end, I settled on Llama 3.1. Nowadays, there's also 3.2, but 3.1 still performs pretty well for this presentation. So that's the one I'm going to use for the next demos, when I'm using a local LLM. So finally, demo time. So what we're going to do, first I have to do a git reset. I always forget, so that's why that one thing is there. So I'm getting rid of all the things we just did with Claude. I'm getting rid of all the answers of Claude. Everything is clean again. And what we're going to do the same thing, prime number generation, but now without all the manual steps. So in its current form, the tool is just a jar file in a different directory, so you can just call it. And what it needs a path to the test file. So you see the test file on top. I'm going to copy the path, and I'm going to paste it over here. And what you're seeing is we're in the first test loop. Within a test loop, you can have 5 code loops, and of both you can have 5, so it does 25 iterations at max. This is configurable, and then it tries to find an answer. Now this one is pretty simple, as you can see. It found one test, that's the one on top of the screen, and this test succeeded. We can take a look at the implementation, but we don't have to, because if you trust your test, you trust the output of this tool. And this is really great. Remember me doing this by hand, a lot of steps. Now I can just write my test and start the tool, grab a cup of coffee and come back. And hopefully I have an implementation like in this case. So the tool works too, and that's really great. Let's take some time to see what the implications are of using a tool like this. So how would you add features? So in the past, I would write more algorithms, right? I would grab my implementation, add some lines of code, and I would have new features. But the implementation is now the field of the AI. I'm not touching the implementation anymore. I'm only allowed to write tests, and that's how you add features. You just write more tests. And that's what we're going to do. So remember the test case with prime numbers? We're going to add a test case for negative prime numbers. So let's go over there. So remember, this is where you could specify the upper bound of the prime numbers to generate. If you put in a negative number over here, you're asking for negative prime numbers. As far as I know, they do not exist. So I want this code to throw an exception. So how do you do that? You just add another test. So like this. I think this is really funny. It's incorrect, but the fact that I have an under 50 and the AI thinks I want an over 50, I think that's pretty cool. Unfortunately, it's incorrect, so I have to fix it. Negative input. Then the AI thinks I need an object called prime number generator. Totally correct, so pretty happy with my AI. And this is incorrect, but hey, still 50%. What we need is something called an assert throws, so this one. So look at that, AI exactly created what I want. I'm going to explain it. So with an assert throws, you first specify the exception that you expect. So I'm going to expect an illegal argument exception. Secondly, you provide a lambda that should throw this exception. So this is how an assert throws works. So I'm going to run over here exactly the same command. I didn't change anything on the terminal. The difference is in the fact that it still points to the file on top of the screen. And that file contains now 2 test cases, you see? It found 2 tests and both tests succeed. Now let's have a look at the implementation to see what changed. And this is the new part. So if you want to add features to your code, you just write a new test. And that feels really, really natural. So what about existing code? So all the demos I just gave, we created something new, but I assume most of us are programmers, so raise your hand if you're a programmer. Yeah, very good, most of us. And you all wrote hundreds, maybe thousands, tens of thousands unit tests in your life. So you could also use this tool and feed it existing unit tests and see what happens. Maybe it comes up with something better than you created. Do you dare to try it? I did. Actually, I used the tool to improve the tool. And that's something I see more often with AI talks. In the tool is something called a code container, and it has a few features. The first feature, it has to hold the code that the LLM produces. Secondly, it has to be able to extract the public class name and transform it in a file name, so we can write the correct file. And the second feature is it should be able to extract the package part, so we can use it to come up with the right folder structure. So I have a test called the code container test. And let me show you what it does. So this test checks the file name extraction part. So I have a few classes, simple classes over here. And notice that I put, you have a normal class, but you have public classes, random spaces in spots. You see like this and this. Yeah. Let me tell you, okay, so I've I started out with a really crappy string manipulation solution. If you have some experience with programming, most people would solve extracting something from this code by a regular expression. But hey, I have a confession to make. I'm pretty bad at regular expressions. So I started out with a crappy string manipulation solution, and that worked until I started adding test cases with those spaces in between. Then everything broke every time. So let's see if the AI can do better. So this is the input. Then this is what I expect. And then lastly, there's a message. I think adding a message is always a good practice when writing tests, not only for yourself, but for the person after you who will use the test. But in this case, it also really helps the AI because it has more information. It knows what it did wrong, and you give it extra information to come up with a better implementation. And we do something similar here for package name extraction. So notice that we have all kinds of packages over here. Notice that we have single level packages, multiple level packages, random spaces again in spots, and also a class without package, because package, of course, is optional in Java. And again, you see here the answers at the end and some messages to help the AI or the next programmer who will touch your tests. What we're going to do, we're going to copy the name of the path to this file. I'm going to go over here. I'm going to get rid of the last input. I think it's this shortcut. Yes, it is. And I'm just going to paste the file. So let's see what happens. So the tool is now talking to Llama 3.1 running locally on my machine, trying to come up with an implementation that passes this test. And yeah, that probably will take some time. Now this is interesting. What happens is we go to the second test loop. That means it didn't come up with a proper code. There was no compiling code in which I could run tests against. And it doesn't look well for, oh, hey, look at that. It came up with an implementation. It found 2 tests, but the implementation didn't pass any test. Now, this is a nice moment to show off the logging. So over here you can see I'm using Ollama on my local machine. It's using Llama 3.1, and I'm using a timeout of 30 seconds. And as you can see, it failed. No solution found. So what do you do when your tool doesn't work? What is the first thing we do? We retry. I'm not sure if anybody said that, but that's what I do. So that's the first thing we do. Well, because we all also know about LLMs that they sometimes hallucinate. Sometimes they're stuck in a corner and they're unable to get out. Yeah, look at that. In 6 seconds, one-shot solution. And this isn't really a simple. It took me some time to write this class, and this is not a trivial problem anymore. So let's see if we can have a look at the implementation. So we have a code container which uses regular expressions like I predicted. As you can see, it came up with a proper regular expression mechanism. So I'm pretty happy with my tool. It saves me a lot of work, and it comes up with better code than I did. Maybe this says more about myself than about you, but still pretty happy. At the beginning of the talk, I told you I'm pretty happy with this tool, but there are 2 major issues. And the first one is we needed to automate, so that's why I created the tool. But secondly, what about libraries and frameworks? So now I have a tool that's pretty capable of coming up with plain Java code, which is nice. But that is not really what we do with work, right? Most people in this room will use libraries or frameworks. And the tool in its current form cannot handle that. So it just doesn't work with the jar file. And there's also difficult problems to solve because the input for the jar file is a test file. And from the test file, it's pretty difficult to extract which libraries or frameworks are used. So I started thinking, how can I solve this problem? And the answer is pretty obvious. You have to do something with the build system. So in my case, it's Maven. And Maven knows about all your dependencies. So therefore, it also knows about the libraries and frameworks that you're using. So I decided to create a Maven plugin. I use Maven because I'm more familiar with Maven than I am with Gradle, but the principle holds and should also work for Gradle. Now, the plugin knows about your dependencies because it's a Maven plugin. I expected it to load all dependencies because I never wrote a Maven plugin before, but this hypothesis turns out to be wrong. It does not load all your dependencies, but the fact that you are a Maven plugin makes it really easy to load all dependencies. So I wrote a custom class loader, and that loads all the dependencies that it can find in your pom.xml. So let's demo this as well. I've created a simple test called the endpoint test, and actually it is a Spring Boot Hello World test. That's what it does. So for people who don't not know Spring Boot test, they look like this. In most cases they have a random port which you can use over here. Sorry about that. So we have a test REST template because we want to do a REST call to our Spring Boot application. We do a get on the root, and we expect it to return hello world. Now, let's run the tool. I told you it is a Maven plugin, therefore we have to take a look at the POM file, which is over here. And there's a lot of stuff in there, but the most important stuff is over here. There's a new plugin called the test-driven generation Maven plugin, and then we have configuration, and its most important input is the fact that you can provide a path to a test file, the same as the jar file. And this file is the file I've just shown you. So what we're going to do, we're going to run Maven test-driven generator, just generate like this. Oh wow, I think I made a typo. Let me see what I did wrong. I think it's test-driven generation. Sorry about that. Generation, like this. Yeah, as you can see, you recognize this, those two lines. It just reuses a jar file I've used in the previous demos, of course. And currently it's talking to my local LLM, Llama 3.1, and it doesn't go really well. So I just told you the first thing that you do when something doesn't work is retry. So that's what I'm gonna do first. But if that also doesn't work, we're gonna start using a cloud LLM, because I'm really happy with the local LLMs, but the cloud ones are still so much better than the local ones. So that's something you can do. And there's a small bug in my tool. Sometimes it doesn't directly release control. You see, there's no terminal, I cannot type. So unfortunately it shows up during the demo, so sorry for that. But we can just retry it over here. So Maven test-driven generate. So we retry. And we just wait. I'll give it a few seconds. If it's still not okay, now I did something, that's already much better. You see, it found one test and one succeeded, so give it a little bit more time. But what we can do, I'm already gonna prepare the POM XML so we can run to a cloud model. And it is really simple. You see some configuration over here. So what I'm saying is use the entrophic family. You can then also specify the model, but there are all kinds of settings you can set in your POM file. I'm going to assume this is not going to work, so I'm going to kill it. And I'm just going to rerun it over here. So the thing that I changed is this line. And if I now go to the log file, generator.log, you see it goes to entrophic and it used Claude 3.5 Sonnet. And look at that, build success in 8 seconds. So let's take a look at what it created. Let me first make some space. I have to do that over here. Then we go to here. It created an endpoint application, which is a Spring Boot application. It is a REST controller. And for people who know Spring Boot, this is how you start it. A get mapping on root, and it returns hello world. This is exactly how I would have written it myself. So pretty well done, Maven plugin. But okay, I agree, this was again a small example. Let's step it up a notch. So what we're going to do, I also created an endpoint H test. So let's take a look at that test. Endpoint H test. So pretty much the same. The idea here is we provide an endpoint with a birth date, and we expect it to come up with the age of a person. And let me walk you through the examples. So if you're born on the first year of this year, you're 0. If you're born on the first day of 2020, you're 4. If you're born on the first day of 2000, you're 24. But if you're born on the last day of 2000, you still have to become 24 and you're 23. So this is the idea. And notice that the age should be part of the URL. So /h/ and then the birth date. Now, I go to the POM file. I change this path because I should use the H test. I go to my terminal and I rerun. And I have to warn you, I would say in 15% of the cases, the local LLM can, it's talking to a cloud LLM. No, it doesn't matter. That saves some time. 50% of the cases, my local LLM can solve this, but this is on the edge what a local LLM can do. So when it becomes a little bit more complex, I switch to cloud LLMs. And as you can see, it generated something in 12 seconds. Let's see what it generated. So now we have an age calculator application. And it made a mistake, interesting. It also, I will get to the mistake in a minute. So it picked up the birth date, should be part of the URL. As a path variable, very good. Then it parses the date that comes in via the URL, very good. And then here's a mistake. It should have used today. And this works, but this is my mistake. This is a human mistake. I only provided 4 test cases because I want to keep this presentation short and interesting. I should have added more edge cases like yesterday, today, and tomorrow. And if you do that, you get a better solution. But then it subtracts both dates, it gets the years, and it returns this. If I would have written this myself, it would take me at least 5 to 10 minutes, and the tool produced it in like 10 seconds. So the business case is pretty simple. The Maven plugin works too. I am really happy because now we have something that we can use at our daily job. So what does work well? Plain Java code. The first few demos were plain Java code, and that works really, really well because the LLM knows about plain Java code. The same applies to well-known dependencies. I use Spring Boot, and the LLMs know about Spring Boot because there are a lot of examples on the internet. So that works also really well. What does not work well? References to your own code. So imagine you have a utils class, and you want the LLM to come up with something that uses your utils class. That doesn't currently work because the LLMs, the public cloud LLMs, do not know about your utils class that you wrote yourself. You can solve that easily, and I will talk a little bit about that in a slide called Future, but currently it doesn't do it. Also, what doesn't work well, less known dependencies. I use Spring Boot because it's pretty popular and pretty well known, but if you write your own dependency and you use it in your project, the LLM will not know about it, of course. So what if it doesn't work? We've seen that happening a few times during the presentation. First thing you do is retry. Second thing you do is you check the logs. Maybe there's a bug in the tool, or maybe something strange is going on. Third thing you do, you upgrade the large language model. You go from local to cloud. And then what if that also doesn't work? Then at least you have the unit test. No, hear me out. So how did I work before this tool? I would write my unit tests. I would grab a cup of coffee, come back and write the implementation. Nowadays, I write a unit test, run the tool, grab my cup of coffee and come back. Hey, and if it works, it's really nice. And if it doesn't work, you didn't lose a lot of time. So I think that is not a bad thing, just spending a minute on running a tool. So pricing, pretty non-existent when you're using a local large language model. Not entirely true. When I'm using those local models, my battery dies a little bit sooner. Therefore, your electric bill will be a little bit higher, but you probably will not notice it. You pay a small price when you're playing around with online AIs, like I'm currently doing. So building this tool, practicing for this talk, cost me about $11. So I think that's doable. And it's pretty pricey when you start using online AIs a lot. Let's say you use this for every test case that you have, then it will cost a lot of money. But on the other hand, every time when it succeeds, it saves you a lot of money because you are the most important, the most expensive part of the project. Humans are the most expensive part of our equation. So every time when it comes up with a solution, you save a lot of money. Especially while models are getting better, cheaper and faster every week. So I really believe in the near future we will have a point in which this is cost effective. Can I use this myself? Yes, you can. So I will share 4 links at the end of this presentation, a link to those slides, a link to the project with the examples, a link to the repo on GitHub that builds the jar file, and a link to the repo that builds the Maven plugin. Little word of warning, it is proof of concept level. Like I told you in the beginning, I wanted to come up with something really cool in 3 to 5 evenings. Didn't work out. Took far much more time. So this is still very much proof of concept level. So be warned. Future. So I see a lot of things I can improve in the near future to make this a more interesting tool. And the first is provide multiple test files. So currently you can provide only 1 test file, and that's not realistic. Normally you have some multiple test files, and adding that shouldn't be that hard. I just need to find the time. Provide context files. I told you, whenever you have a utils class, it doesn't know about it. If you would provide your entire context of your project and send it to the large language model, it would know about your utils file and therefore would use it. Also, small fix. Now, yeah, small fix. It takes some time, but it's not. I can see it in my mind how it should work. Currently, the tool only accepts if the LLM comes up with code for exactly 1 class, but sometimes it comes up with multiple classes. The tool cannot handle that. Sometimes it comes up with partial implementations, especially when you're going through the upper loop. So it comes up with the first implementation, and then they say, this test didn't work. It says, oh, replace this method with that method. The tool currently cannot handle that. Hybrid mode, I really love to work together with AIs. So you as a human write the first version of the implementation, and you leave to-dos for the AI. Implement this, implement this, implement this. Currently, I support Llama, ChatGPT, and Claude, but there are far more AIs out there that I would like to use. Currently, it only supports JUnit 5. Of course, you can easily add JUnit 4, but maybe you want to use Spock or something else. So I would like to support more. Then currently, it only works for Java. I think it's easy to add Kotlin, but the principle holds for every language. So it should work for every language. My end goal is to make this an IDE plugin. So picture this, you're writing a unit test, you right-click in your IDE, generate implementation, you grab your cup of coffee and you come back. Would be perfect. I specifically said my endpoint because I think there's another endpoint for this idea, and that is part of Copilot, AI assistant of DevOps Genie. I think this should end up in one of those tools. Actually, Stefan asked me if I could make it part of DevOps Genie, and I really would love to, but I don't have the time. So I have a question for the audience. If you have the time, pick this up, and probably next year you can stand here. Big chance, big chance. But if there are people in the room who are willing to make this part of DevOps Genie, please ping Stefan or ping me, and we will make this happen. Conclusion. TDD and GenAI is a perfect pairing. I've shown multiple demos in which I showed off the fact that the principle works. And yeah, you can just use it, you can play with it. The most important thing that I can teach you today is that you have to check the output of large language models. I've given you the example of Air Canada. Lucky for us, we have a way to check the output of the large language models, and that is using unit tests. And that's what this idea does. Thank you for being here. If you have questions, please come to me after the presentation down here. I prefer my questions one-on-one. Feedback is more than welcome. Please rate my talk in the app. If you just have feedback, you can come over here, talk to me in the hallway. Notice that there are QR codes in the bottom. Those are the 4 links I promised. And last mandatory bullet from the HR department. We are hiring. If you're looking for a cool new job, talk to me. Thank you. I hope everybody learned something new. Enjoy the remainder of the conference. Bye-bye.